Welcome back. So today we will solve all the questions from Parabola which came in different shapes of April 2025 attempt. In Parabola we have total 6 questions, out of which 3 are easily doable and 3 are moderate, which we are going to solve. This difficulty level is basis my perception, which may be different for others. And also here is our analysis page for each and every question. We have total 6 questions and here are the topics and concepts for each questions. Hope this will be helpful for you. Here is our first question. Our question says, let the focal chord PQ of the parabola y square is equal to 4x make an angle of 60 degree with the positive x-axis where P lies in the first quadrant if the circle whose one diameter is PS, S being the focus of the parabola, touches the y-axis at the point 0, alpha, then 5 alpha square is equal to. So here in this question, first we will make graph and then proceed to the question. So here is our parabola. Here is our parabola. And let's say this point is focus. This is P. This is S. And this point is Q. Here is the rough graph. Now let the focal chord, we have a circle which has PS as diameter. Please wait a minute. Yes. Its diameter is PS and it touches y-axis at 0, alpha. Midpoint of PS will be the center for the circle. And angle of the focal chord from x-axis, this is x-axis, this is y-axis, will be 60 degrees. 60 degrees. Now this is our parabola y square is equal to 4x. So focus will be 1, 0. Now let's assume P. Our P will be A, which is 1 T square, 280, which will be 2T. Now tan of 60 degree is equal to 2t minus 0 upon t square minus 1. From here we will get root 3t square minus 2t minus root 3 is equal to 0. Now on factorizing this equation we will get t minus root 3 and root 3t plus 1, root 3 minus 3t plus t, yes, is equal to 0. From here our t is equal to root 3 minus 1 upon root 3. Now minus 1 upon root 3 will be rejected and root 3 will be accepted because our point P lies in the first quadrant. So from here our P will be 3, 2 root 3. From there our center is equal to 2, root 3, and because C So from here it touches y-axis at 0 comma alpha. Then this is from here alpha is equal to root 3. Alpha is equal to root 3. Yes, alpha is equal to root 3. So from here our 5 alpha square is equal to t. So our solution is option A. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says, let the point P of the focal chord PQ of the parabola y square is equal to 16x be 1 comma minus 4 if the focus of the parabola divides the chord PQ in the ratio m is to n, GCD of m comma n is equal to 1, then m square plus n square is equal. So again in this question, first let's draw the graph. So this is our graph of y square is equal to 16x. And our point P will lie in the fourth quadrant. This is y-axis, this is x-axis. Our point P will lie here in the fourth quadrant. And PQ is focal chord which passes through focus. And focus for this parabola will be 4, 0. Now our P is 1, minus 4. And in parametric coordinates of y square is equal to 16x, we can write as 4t square comma 8t. From here in our point P we have t is equal to minus 1 upon 2. So we can say that if PQ is a focal chord, then the t for Q will be minus 1 upon t of P. So this will be 2. From here our Q will be 16, 16. Our Q will be 16, 16. And the question asked us about PS is to SQ, which is equal to, let's say this is M and this is N, which is equal to PM upon QN. So PM will be 1, PM will be 4 and QN will be 16, which is equal to 1 upon 4. From here m square plus n square is equal to 70. Our answer will be option A. And here is our solution, and we can see that our answer is correct. Here is our next question. This time our question says the radius of the smallest circle which touches the parabola, these two parabolas is. So first again in this question we will plot these two parabolas and then we will use some symmetry to solve the question. Our y is equal to x square plus 2 parabola will be like this, and x is equal to y square plus 2 will be like this. Now this is y is equal to x square plus 2. This is x is equal to y square plus 2. Y-axis, sorry, x-axis and y-axis. Now, the circle radius of the smallest circle which touches these two parabolas will be this circle. This circle. And here let's say we have a common tangent. Yes. Here is our common tangent. Now these two curves are very symmetrical to the coordinate axis. So from here we can say that this line is y is equal to x. And let's say this is our P and this is Q. So let's take first derivative of y is equal to x square plus 2. Y is equal to x square plus 2. Y dash is equal to 2x. Now 2x is equal to slope for this common tangent is equal to slope for y is equal to x, which is 1. So x is equal to 1 upon 2. Now our x is equal to 1 upon 2, we will substitute in the above equation. Then we will get y coordinate is equal to 9 upon 4. From here, our coordinates of P are 1 upon 2, 9 upon 4. Now we need to find the radius. So radius will be distance of point P to the line y is equal to x. So our required radius is equal to mod of 9 by 4 minus half upon root 2. This will be equal to 7 upon 4 root 2. We can write it as 7 root 2 upon 8. So here we have our radius. So from here our answer will be option D. And here is our solution, and we can see that our answer is correct. Here is our next question. This time the axis of a parabola is the line y is equal to x. So this is the axis of the parabola, and its vertex and focus are in the first quadrant at distances root 2 and 2 root 2 units from the origin. Respectively, if the point 1 comma k lies on the parabola, then a possible value of k is. So first again let's plot the parabola. Now here we have this as axis for the parabola. And here is our, let's say, parabola. Our vertex will lie on the line y is equal to x, and same for the focus. Now our focus is 2 root 2 units far from the origin. It lies in the first quadrant and also on the line y is equal to x. So from that we can say s is 2, 2. Distance between origin and s will be 2 root 2. And same for vertex v, it will be 1, 1. Now distance between vertex and the focus is root 2. So distance between vertex and the directrix will also be root 2. So from that our directrix will be x plus y is equal to 0. Now here we have our directrix. Let's say now we need to find the equation of parabola. Let's say here we have random point P. Distance from S to P is same as P equal to directrix. PS is equal to PM. From here we will get x minus 2 whole square plus y minus 2 whole square is equal to, now we are taking square both sides at the first step, and let's take 2 to the left hand side. On the right hand side, PM will be, from here our PM, x plus y is equal to 0 PM. Please wait a minute. Yes, it will be mod of x plus y upon, x plus y whole square. Now, if x is equal to 1, we will get 2 times 1 plus y square minus 4y plus 4 is equal to 1 plus 2y plus y square. So from here we will get y square minus 10y and minus 9, plus 9 is equal to 0. So y is equal to 1 comma 9. From here our y will be equal to 9 because the question is saying possible value of k. If we will take y is equal to 1, the point will be vertex. So y is equal to 9 will be a possible value of k. Our option B will be correct. And here is the solution, and we can see that our answer matches correctly. Here is our fifth question. Our question is, let P be the parabola whose focus is minus 2 comma 1 and directrix is this. Then sum of ordinates of the point P whose abscissa is minus 2. So here, unlike the previous question, we have straightforward focus and directrix. So it's very easy. PS is equal to PM. PS is equal to PM. PS, we will take square both sides. We will get x plus 2 square plus y minus 1 square is equal to we will take 5 to the left hand side. On the right hand side we will get 2x plus y plus 2 whole square. Now our abscissa is equal to minus 2. So we will get 5 times minus 2 plus 2 will be 0. So 5y square minus 10y plus 5 is equal to, this is minus 4 plus 2 will be minus 2y minus 2 whole square, which is y square minus 4y plus 4. So from here we will get 4y square minus 6y plus 1 is equal to 0. And we need to find sum of ordinates. So y1 plus y2 is equal to 6 upon 4. You can write it as 3 upon 4. So from here our solution will be option A. And here is our answer, and we can see that our answer matches correctly. Here is our next question. This time our question says, let R be the radius of the circle which touches x-axis at point a comma 0, a less than 0, and the parabola y square is equal to 9x at the point 4 comma 6. Then R is equal to, so here in this question, let's again draw the graph first. Yes. Let's say here is our circle. It touches x-axis at a comma 0. It touches x-axis at the point a comma 0, and the parabola we have y square is equal to 9x, and here is our tangent, common tangent of parabola and the circle. Now these two curves touch at 4 comma 6, and let's say this is center. This will be our radius r, so center will be a comma r. Now we can write the equation of circle as x minus a square plus y minus r square is equal to r square. Our point P, let's say this is P, point P 4 comma 6 lies in the circle, so 4 minus a square plus 6 minus r square is equal to r square. From here we will get a square minus 8a minus 12r and 36 plus 16 plus 52 is equal to 0. R square will get cancelled. Now let's write equation of tangent using parabola. Our equation of tangent using parabola will be y1, so y into 6 is equal to 9 times x plus 4 upon 2. From here we will get 3x minus 4y plus 12 is equal to 0. Three x minus 4y plus 12 is equal to 0. Now our CP, center and the distance from point P, is equal to R. our CP will be distance of tangent and the center. So from here we will get 3a minus 4r plus 12 is equal to plus minus 5r. So from here we will get 3r is equal to a plus 4. We are taking plus first and then we will get, while we take minus r is equal to 3a plus 12. From the first one we will substitute r in the first equation. We will put these values in this equation. So we will get a square minus 8a minus 4a minus 16. So this will be a square minus 12a plus 36 is equal to 0. Now this is a minus 6 whole square. So from here our a is equal to 6, which will be rejected. Now let's come on to the second equation. Well, also one more. This is rejected because a is less than 0 as given in the question. Now from the second one we will get minus 3a. So this will be 36 minus 8. So a square minus 28a and 14452. It will be plus 196 and also plus 28a, not minus, plus 28a plus 196 is equal to 0. Now again this quadratic equation is a plus 40 whole square. So from here our a is equal to minus 40, which will be accepted. So from here, if a is minus 14, then r is equal to, using this equation, 14 into 3 will be 42 minus 42 minus 12. So r is equal to 30. From here our answer is equal to 30, and here is our solution, and we can see that our answer is correct. So hope you found this video helpful. Thank you for watching.